Hello, today we'll design a PCB for an Astable Multivibrator, also known as your LED flasher. So you can mark this is the circuit we want to design. Let us copy the circuit, open KiCad, go to File, New Project, give some name, LED flasher. Make it 40 slightly. We can visualize it in a better way. Okay, so okay, now you can see these lines are more clear. You can, or otherwise we can slightly reduce that. It is more 25 I make it. Okay, now it's looking good. Try to make the wirings here. This pin is connected to this one, again to this one, from here to this point. All resistance are connected, and from this resistance to this one, from slightly. Okay, then from here to here, and then from this point to capacitor F. Let me drag this capacitor slightly below. Sorry, first of all we need to select this capacitor. Okay, now it is selected. Now bring this down to this point, then it will be better. Then again we select this one, bring this slightly down, then again we start wiring. Now here this resistor to the LED, then from this LED to this terminal of the your collector of this second, not connected here. Okay, we'll see that, we'll check that which are not connected. We'll check that once we complete this. Okay, now from this point we connect to the base of this second transistor. Similarly from this point we try to connect here. Okay, it is not connected. Let me, we'll see that what will happen. Okay, now you connect here, then from this point it has been connected to this way. Now I think this part is over. Next we connect these 2 points. Next one, we have to ground it. These resistors need to be connected to these points. To connect it, this is, you can connect it to this point. Okay, now all the connections are made. There may be some disconnections or no connection, so we will check one by one. Now before that, we have to connect this power line to this point and also a ground point. Okay, now ground, here you need to check G and D. Now this ground we connect this point. This is the ground. Let me add the wire between this ground and this point. Okay, so now our circuit as per the diagram, so it has been done. Now let's delete this. No, so we need to first uh, write the values of these components. So let me drag this to slightly this one so that we can make a zoom out of it. So here this value, this is R1, and the value I can put here at this place. By double clicking, this window will pop up, so I can write here 470 ohm. Okay, so text size is written 1.27. If I want, I can also change the text size at this point. Now you mark, it has been added here. This is your 470 ohm. Now the second one, this is LED. This LED we need to, it's D1 reference LED is this one. Okay, this value I can take this value slightly up here, and this LED also to this point. Okay, this is the first LED. Similarly, now if we double click here, the capacitance value is 10 microfarad, so I can write 10 U F. Okay, so it is 10 microfarad, it has been written. You can drag it slightly below this one, and also this capacitor you can drag here. This is the indicating the value and the name of that capacitor. Similarly, this Q1 is correct, so this is your, slightly I can move to this side. I hope it is not coming, that's no problem. Okay, then we'll see other values are similarly. This value R2 is 47k, so I can write 47k in kilo ohm. This value R3 is 47k once again. Okay, then the fourth one is 470 ohm. Okay, then this is the capacitance value again. This value is 1, it is again 10 microfarad. Okay, so if we can bring this nearer to this, and also this capacitance, the name of this capacitor is C2. Okay, then next one is LED is a D2, and it's name of this one. So if we want to, one thing we can do, we bring that to this side so that this will be better. This R value I take this side. Okay, similarly this is Q2, and we right here inside this, and also we keep this, try to keep this D2, it is LED, that is inside this. Okay, so all the names are now written, the figure is drawn. Now this terminal, we call it as terminal ST. it has 0.25. Copper layer is a 0.2 millimeter. Text to it this much. So edge chords is 0.5. Every dimension you can adjust by yourself. One and holes 0.5. Okay, so these things. Then we have this. These are the dimensions, patterns, net classes. Here you mark the net class. Default clearance is 0.2 mm. Track width 0.2 mm. Via size 0.6. So all these things are predefined. If you want, you can also change this clearance according to your wish. So now everything set. We need to draw this. We need to arrange this according to our figure. So first one, this is the connector switch. Let me put here. First let me check one by one. We'll see. These are the two LEDs. Let these two LEDs are apart from each other. They are okay. Now this resistances R1 and R4, they are somehow I put there on this D1 I put in this side, D2 I put here. Similarly, let me take this capacitor here and this capacitor to this place. R1 I this one, let R2 I take there this point, and then R3, and finally R4 to this side. Okay, now let us arrange this. This is your Q1 means transistor 1, and this one is transistor 2. Let's keep this in this way. Okay, now let us rotate this. So we can rotate here, this one R1, then I can keep this one R2, then R3. Okay, so as we have placed that, R1, then under this R1 we have our LED. So I can rotate the LED in this manner so that this will be like this. I can put here. Similarly, second resistance I can keep at distance so that we can put the capacitance in between this 1 and 2. These are the capacitance values. Now I can take this one to this point. Okay, then this value here, this transistor, then you take this LED slightly lower. You adjust by yourself, no hard and fast rule in this place. So we rotate this distance so that it will be adjusted at this point. Okay, that's the case. Then slightly we have to, I can now this capacitance can this can be rotated in that manner. So back here. Okay, now this diode we can put like this. Okay, So I hope all these components are placed. Now let me check. Click this bottom copper because we are going to route that copper lines in the bottom side of the wiring. So here I can rotate this. Let me rotate this one. Okay. And I can bring this to this place and also rotate in a other way. Okay, in that manner if you can rotate, then it is easier, I hope. Let me check once which will be connected to what. Okay, let me check. This is your wiring routing. So from here these resistances are connected. Sorry, let me increase the size width. Let me change this to 1 mm width of the wiring from here to here, then from this point to this point. Okay, then again from this point to this point. So all are connected now. Now if we simply connect this to this point, okay, escape. So we require to rotate this one as this side is connected. Okay, now let me draw this and check whether it is okay, it's good. Now this line is okay. This is one connection. Similarly, this has to be connected to this point. This one. Next one we can connect from this point to this point. Okay, let me rotate that. Escape. Select this LED and rotate once, so it will be in the same side, so that it will take less copper wire to connect. Now it is connected. Now from this point we need to connect it to this point, but let me try next one. From here to here we need to connect. Okay, now it's good. Then from this point we need to connect to this point. No, it's not. Delete it. And similarly we have a connection from this point okay, these points to this point, then connect. Then from here we have a connection to this point, then at this point I need to rotate this one so that it will be not overlapped or intersect each other. Let me check 1 second what will happen. Wait. so that it will be better. Okay, let us try once again from this point. Okay, now this point is connected to this point. I hope I have connected all the points. Now this point should be connected to finally this is grounded. Let us check this by whether these connections are correct or not. Let's check it by running this design rule checker. So we have three errors. First one is no edge found on the edge cords layer, and we have two overlaps, cell screen overlap. Let me two warnings are there, three errors. What are the three errors? Okay, close. Now we go for edge cords, this one. Now let me draw this edge cords. Okay, edge cord, this is your edge cord. Then select a rectangle. After that we can select this, and this is your edge cord. Okay, rectangle, edge cord, select this, then we select this one, and you'll find click here. So this is your edge cord. Now we need to fill those gaps with copper. The ground, we have not taken any ground, so ground will be automatically taken care by filling this. So let me check it. Cancel. Let that ground is your bottom copper. Select this, then select this ground, then OK. Then we will start from this point. Select this, start from this point, ground, OK. Then we'll check this line. Then from here you can draw like this. Then from this point we can draw here, and finally we have to draw this one. Okay, so now it has been drawn. Now let us run that rule checker. Run the rule checker. Two violation unconnected items are there. One errors, let me see. So these are the errors you can mark. First error is board edge clearance violation. Board setup contains edge clearance 0.5 mm, actually 39 mm. So all the cases, that is edge clearance violation. Edge clearance is 0.5 with that, but it is of actually we have 0.39. Let me connect my charger, laptop charger. Okay, so now edge clearance 0.5, actually we have 0.39. So let me draw the edge again. So select this and delete this one. Edge, again delete it, slightly reduce the size. Now go to that edge cords. From edge cords go to this draws rectangle, take slightly bigger dimension so that it will be more than 0.5. I hope this will be sufficient. Okay, let me select this from this point. .5 here, escape. Oh, delete this one. Once again, try it from this point. So I think it is slightly more than that previous one. Then again we move to this copper, go to this drop field zones, then I can select from this point. So now ground, okay, draw this. Okay, let us once again check the design rule checker, and you mark there will be no errors. So now this is our PCB. Let me check the 3D. Let the full view here, you can mark the 3D picture. This is your 3D picture. So as we have discussed, in this manner we have placed the components, and behind it we have all the wirings, this one. Okay, so now we can save this. File, export current view as PNG, save here. Once again we have to check it. File, export, save here so that it is useful. Okay, now from here we can generate the file, then fabrication setup, then Gerber file. Now all the layers, required layers we have selected. Generate drill files also, generate drill files, done, close it, then plot all other files. Now everything has been generated, then close this. Let us see which files are generated. So this is your Gerber file, you can mark. This is our Gerber file. This is we can take for fabrication. Then we have your LED flasher mask. Let's say how it is look like. This is the mask. Then your silk screen not top, this bottom silk screen will be there. So here you will have front silk screen. This is the silk screen, this is the component arrangement. It will come on the front side or the top side of the PCB. Then we have through holes. These are the hole points. Okay, so this is all about. Then we can take this Gerber file and we can also print this. Okay, so print preview, we can see. So our PC will look like this. We can take it for laser printing, or we can take it for chemical etching process printing. Okay, we'll stop here. Thank you.